Hello everyone. Today I would like to bring you with me throughout my day. I have some work to do in this construction site. I'm an electrical and electronics engineer. So this is the main electrical room where the main distribution panels are installed. This is the main circuit breaker. If I'm not wrong, it is 1250 ampere. Let me double check. Yes, it's live, by the way. These are the distribution circuit breakers. These are also some circuit breakers. This is the compensation panel. This is the panel for the UPS. The UPS is in the other room. Now, what I am here to do today is I want to look at this panel. This panel is for the solar panels. So basically, these cables, we have a total of 4 inverters in this construction site. Each one of them is 100 kilowatt, and I'm here to see what they have done here, check everything, run some tests. So basically this is the main circuit breaker which goes to the main distribution panel. These cables, the ones that are taped with yellow, are the cables that are coming from this panel, these ones. So basically energy comes from the inverter and supplies the load directly. These cables are coming from the transformer directly, 240 millimeters square each one of them. For each phase we have 4 cables. I think also for the neutral we have either 4 or 2, I'm not very sure. Anyway, this is for the RCD core. Of course, cables will later be connected to it for the for this relay, so that if there is any leakage it will trip. So the main circuit breaker that is connected between the inverters and the load should be motored. So there should be a motor here. This is the motor mechanism, and this is the circuit breaker. So I have tested this panel, the panel responsible for the solar power. There are a few problems. For example, this is the emergency stop button. The dry contact of this button is not correct. Basically, they have used normally open, but it should be normally closed, because when I press on it, the panel works and the motor, the circuit breaker, starts working. See, it gives the phase to this relay, which is responsible for the any unbalance movements in the grid. If there is any unbalanced movement, it will trip. Anyway, so with that being pressed, with the emergency stop button being pressed, this relay energy comes to this relay. Basically, the cable coming from the emergency stop button is this. So it starts operating. Anyway, and it gives contact to the motor, the circuit breaker, and it works. So basically now I can see if I switch that to automatic, it will be closed and there will be energy here. Let's see. Here we go. Now, if I pull that back, see, energy is gone. So, just the contact is wrong. Not a big deal. Other than that, these can be modified. They are so close to each other. Other than that, this should be organized. These are the communication cable between the inverter, RS482, I think. Other than that, these cables should be turned into a bus bar. That's it. So basically there is a separate room for the UPS. This is the UPS. Disgusting work. Anyway, but for the UPS to, have some airflow for cooling purposes, it is good. These are the battery groups covered. These are the circuit breakers for they are not circuit breakers, they are fuses, big fuses made from ceramic, I think. These are disconnected, of course. The red cable is plus, the black cable is minus, and the blue cable is basically the middle point, the neutral of the batteries. So you have a plus and minus. You have a plus 600 and minus 600, not plus 1200 volts. This is how big UPSs works. Anyway, this disgusting work will be, of course, removed and modified. As far as I understood, this is a fire extinguisher. It emits, that white powder that is used in fire extinguishers. This device is only placed in a few rooms, a few places. One of them is the UPS room. The other room is, I think, the server room. And I think it is, yes, it is placed in the electrical room. So basically this is the main entrance, and there will be, the metal detection device. It will be placed here, and these devices will be placed here. Of course, the cables are not enough. Each one of these need communication cable. Usually instead of a communication cable, we use Cat6 Ethernet cables. Each one of these need 4 cables. In the entrance you have a card reader, and in the exit you have a card reader. Each one of them needs 2 cable, one for communication with the main unit and one for giving contact to the device, to the door to open. These are the two generators supplying the whole building. Each one of them is 440 kilowatts, not kilowatt, kilovolt ampere. This is the köşk, is called in Turkish, which is basically the place where transformer is placed and where the medium voltage is coming. The medium voltage is coming from that köşk using XLPE cables. This is the disgusting earthing, which will be modified, of course, to not be kept in this way. This is inside the köşk. There is energy. Here we go, and that's the transformer. Let me show it to you. This is the transformer, 1 megawatt. These are the output cables and these are the input cables, the medium voltage, and this is the low voltage. The main circuit breaker is also 1250 ampere. This is the transfer panel, automatic transfer panel, where basically the energy from the transformer and from the generator are combined. Of course, each one of them has a different motor circuit breaker. These cables, of course, will be replaced just temporarily before the synchronization happens, because these two generators need to be synchronized with the grid and also with each other. Each one of these generators also have a motorized circuit breaker. You see that panel? This panel is responsible for pulling out the water from under the ground to the building. Of course, it first goes from under the ground to a tank. This tank, of course, is made from concrete. Then from that tank to the building, the pulling operation is basically done by a motor.